execution cycle. So cycle through which instructions residing in memory units are executed by the processor is known as instruction execution cycle. So it basically consists of 4 cycles. First one is fetch cycle, second is decode cycle, and last one is execute cycle. The CPU fetches the instructions one at a time from the main memory into the int registers. Then CPU decodes the instruction, and at last CPU executes the instructions. And this process is repeated until there are no more instructions. In simpler computers, instructions are executed sequentially. In most modern computers, instructions are executed parallelly.
According to memory address, the instruction bit is fetched by giving access to the memory unit to send the instruction bit stored in information register. In the decode cycle, instruction bits in information register are encoded and operands are decoded. This means the instruction bit in IR will tell you what register stores and what ALU operation is being performed. In execution cycle, instruction is performed as per ALU operations and result is computed and stored in a Z register as seen in earlier diagram. Data on this Z register will be put on the data bus and will be stored in another register where we can see it. So, the first operation in the whole process is PC out. PC means the program counter. The content of register get loaded on the bus during PC out action. After this, the data on data bus get loaded into the memory address register. This process is done under the action of MAR. Next command is select 4, which is a multiplexer. Select 4 adds 4 bit to data to get the count of next program with help of add command. Output of this data is temporarily stored in Z register. Using PC out, this data is again put on the bus, then loaded into PC register which will give the location of next program. After this, MDR out places the data of instruction on the data bus. Whatever data is placed on the data bus is then transferred to an instruction register. Now, the content of R3 register is placed on system bus. After the MAR, whatever data is placed on data bus is then transferred to an instruction register. Now, the content of R3 register is placed on system bus. After this, MAR in transfers the memory register.
Hello everyone, my name is Pranay and I'll be telling you about the basic command in this cycle. So before that, let us take a look at the structure and connectivity of the register. So as you can see in the diagram, the registers are labeled from R0 to Rn-1. Temp is the temporary register. Next up we have the Y register. MUX is the multiplier. ALU is the arithmetic logic unit. Z is the register where results of the ALU are stored temporarily, and the arrow in the middle is the bus. Since this is a single bus architecture, it can only carry one instruction at a time. Coming on to the basic commands, first up we have is out. So out is basically when data from the register is taken out onto the bus. Then we have the opposite of out, which is in, and what happens in is data from the bus is put onto a register. Next up, we have a very important register, which is the MAR, the memory address register. So what the memory address register does, it holds the address of the memory or the register from where the data is to be read. After that, we have the MDR, which is equally important. It fetches the data from the register with the help of MAR. So they work in unison to read the data. Next up, we have the write command, which is self-explanatory, and the last function would be WMFC. So WMFC is the short form for wait for memory function completion. So basically, what happens is that between two instruction cycles, the WFMC command is issued, and during this, the processor stops, checks whether all processes are completed in the cycle, and then starts the next instruction cycle. Thank you.
So the instruction add R2 and R1 is basic assembly language in instruction that performs an addition operation on the contents of two registers R1 and R2. The instruction is typically executed as part of instruction execution cycle in a computer's central processing unit CPU. In the instruction execution cycle, the instruction is first fetched from the memory and loaded in the instruction register. The instruction is then decoded, which involve the operands then fetched from their uh, respective register. The result is then stored in the destination register.
Set of commands in the instruction execution cycle. What we do is, starting from the fifth one, what we do is we first put contents of register R1 out on the system bus, which is denoted by the instruction set R1 out. After that, we put the contents of this register 1 into register Y, so that what this means effectively is the contents of register 1 are already out on the system bus. Now we put contents of that in register Y. So R1 out, Y in, which means whatever contents are there on the system bus are now being put into Y register. Then WMFC means wait for this memory function to complete, or wait for memory function completion. Next, we move out to the sixth command, which is started by MDR out, which means whatever contents are there in memory data register are now being put out in the system bus. After that, we have the select Y command, which applies specifically to the multiplexer. So the multiplexer has a number of registers connected to it. Now, whenever we say select and whatever register name we give after that, it means that the contents of that register are selectively gated onto the system bus.
Now U में अपन add करेंगे, it will store this in the Z register, which means whatever the data is added put onto the bus is going to be stored in Z register. Okay, done. That much is understood now. What the last function is, a simple function is remaining, is Z out. What this means is Z ever the contents of the Z register, which are the addition of R1 and R3, put them out on the bus system bus. And what do you do next? Will you put them in R1 simply, which means that whatever the data is on the system bus, now put them in register 1, and that's it.